Hello everyone. Let's solve one more question from atomic and molecular physics. The question is diffuse hydrogen gas within a galaxy may be assumed to follow a Maxwell distribution at temperature 10 per 6 K Kelvin, while the temperature appropriate for the hydrogen gas in the intergalactic space following the same distribution may be taken to be 10 for 4K. Okay, the ratio of thermal broadening, that is delta nu g for gas divided by delta nu for Ig, that means intergalactic. What is the ratio? You have to find out of the Lyman alpha line from the hydrogen atom within the galaxy to that from the intergalactic space. How much? See here, the thermal broadening is we have to find out. So when we talk about the thermal broadening or the diffuse of hydrogen gas or any gas, there would be come one thing in our mind, that is Doppler broadening or Doppler shift. So what is Doppler shift? Doppler shift is that uh, the Doppler shift arises due to the thermal motion of atoms. Let me write. Doppler shift arises due to thermal motion of atoms, in which frequency of atoms traveling towards a detector is different than the central frequency. Okay, see that Doppler shift arises due to the thermal motion of atoms, in which the frequency atoms traveling towards the detector is different than the central frequency. So that the transition in frequency arises, and there will be shift arises also. So that Doppler shift is equal to 1.67 nu naught. Nu naught is the central frequency, and 2 kT by mc square whole root. M is the mass of that atom, that gas which contain that atom, and then K is the Boltzmann constant, T is the temperature. So here only giving the information about temperature of gas and the intergalactic space. Okay, so our proportionality is thermal burning delta nu is proportional to root T. So delta nu g divided by delta nu Ig is equal to T1 by T2 whole root. So here T1 is 10 per 6 divided by 10 per 4 whole root, that will be 10, and this is the answer. There is no use of Lyman alpha. That is also only showing that the Lyman alpha line from the hydrogen atom, that means hydrogen atom of that Lyman alpha line. Okay, and you don't have to be confused about these lines. We have to focus on the thermal broadening, how it happening, or what is the relation between the thermal broadening and the with temperature and its central frequency. Okay, so here option is 3, so that is the answer. Okay, thank you.